Every day, from hundreds of kilometers up, satellites photograph the surface of the sea. But the ocean is not a surface. It is thousands of meters of moving water, and almost none of it is visible from space. This is how we see the rest, and how scattered measurements become a single, living map of the ocean. There is a myth I hear constantly, even from scientists, that Copernicus is satellite data. It is not. Not only that, when you download temperature, or chlorophyll, or currents, you might be getting a satellite reading, a model result, or a careful blend of the two. Knowing the difference is the whole game. Everything the service produces comes from three kinds of eyes: satellites, watching the skin of the ocean from orbit; instruments in the water; floats, moorings, ships, feeling the interior directly; and numerical models, simulating the physics and the biology in between. They do not compete, they correct each other. Start with the satellites, because that is where the misunderstanding begins. A satellite is a camera pointed down. It reads the radiation leaving the very top of the sea. The skin, a layer thinner than a coin. 10 meters down, it sees nothing. 1,000 meters down, nothing. That blind spot is the reason the rest of the system exists. From that thin skin, we still pull a great deal. Thermal infrared sensors read sea surface temperature. Ocean color sensors read the light leaving the water, and from its shade, estimate chlorophyll, calculated, not measured, and radar altimeters time a pulse to the sea surface and back, mapping its height to the centimeter, and from that height, the currents and the eddies. This did not happen overnight. Seasat opened the era in 1978. Topex Poseidon rewrote sea level science in 1992. CYFS gave us the first global map of chlorophyll in 1997. Then MODIS, the JSON altimeters, and from 2016, the Sentinels, the satellites Copernicus leans on today. In 2022, SWOT began resolving features we had never seen. But put a cloud over the Bay of Bengal, and infrared goes blind, ocean color goes blind. At night, some sensors simply switch off, and none of them ever reach below the surface. On any given day, huge stretches of ocean are missing from the satellite picture. So the water reports on itself. Nearly 4,000 Argo floats drift the world's oceans, sinking 2 kilometers down and rising again, measuring temperature and salinity the whole way. Add moorings, gliders, and research ships, and the interior comes into focus. Everything the satellites cannot reach. Now the heart of it. A model runs forward, predicting the ocean hour by hour. Then the real measurements arrive, where the model and the world disagree. The model is pulled back toward reality. Predict, compare, correct, repeat. The same trick your phone uses to keep finding you. This is data assimilation, and it is what makes Copernicus more than a pile of numbers. The engine underneath is a model called NEMO. It solves the equations for how water moves, warms, mixes, and layers by density across the entire globe, driven at the surface by Europe's weather forecasts. Fold the observations in, and something remarkable falls out. A full 3-dimensional ocean, temperature, salt, and current at every depth, even where no instrument has ever been. 2 kinds of numbers come out. Primary variables are the fundamentals: temperature, salinity, sea level, and the core chemistry, nitrate and oxygen. Secondary variables are never measured at all: density, mixed layer depth, geostrophic currents, primary productivity. Each one is built from the primaries by physics. Much of what you download is, honestly, a calculation, a good one. Biology gets its own engine. A biogeochemical model follows the cycle. Nutrients feed the phytoplankton. Phytoplankton feed the zooplankton. The dead sink as detritus and dissolve back into nutrients. Run it beside the physics and you can forecast oxygen, carbon, and the plankton themselves. And you can ask it about any time. Analysis is the ocean right now. Forecast is about 10 days ahead. Reanalysis is the whole ocean rebuilt across decades, the most accurate history we have. The flagship, Polaris 12, resolves the globe to 8 kilometers, 50 layers deep, from 1993 to today. Along the coast, Sentinel-2 sharpens that to 100 meters, fine enough for a single delta. So remember this: Copernicus Marine is not a satellite database. Satellites read the skin, floats read the deep, models supply the physics, and data assimilation stitches them into one ocean, past, present, and future, Whether you are tracking a marine heatwave or mapping a nursery ground in the Bay of Bengal, that is the ground you are standing on.